A geneticist is interested in the proportion of males and females in the population that have a certain minor blood disorder. In a random sample of 100 males, 41% are found to be afflicted. In an independent sample of 150 females, 24% have the disorder. Can we conclude at a significance level of 5% the proportion of men in the population afflicted with the disorder is greater than the proportion of women who are afflicted? Okay, to start with, we have a couple sample proportions already given to us. Let's let group 1 be males. So we have a proportion of 41% or a p-hat 1 of 0.41. And for the females, we have 24%, so p2 hat is 0.24. When you're doing a hypothesis test for proportions, you also need the common p-hat. And in order to get that, we need counts of how many people are afflicted here. So let's take our two sample sizes, 100 for the males and 150 for the females, and let's extract from that the number of people that are afflicted. If we take 0.41 times 100, we'll see that that's 41 people who have the disorder out of 100, and if we take 0.24 times our 150, we'll get that there are 36 females that have the disorder. So our common value p-hat is our two numbers of people afflicted added together divided by our total number of people. And this will give us 77 out of 250, which is approximately 0.308. So let's set up what we're going to actually be testing for here. We want to find out if the proportion of men or males that are afflicted is greater than for the women. And so when we do our hypothesis test, our null hypothesis is that the difference in proportions is 0, or you can write this equivalently, if you want, as P1 equal P2. If we want to find out if more men are afflicted, and we have called the group for the men group 1, what we want to find out is if this difference is positive. And this is equivalent to saying that P1 is greater than P2. So we get our test statistic Z by taking the difference in our sample proportions on the top, and then in the bottom we divide by our p-hat times 1 minus p-hat over our sample size for group 1, which is 100, plus p-hat times 1 minus p-hat over our sample size for group 2, which is 150. And what you'll get for this test statistic is 2.85. We're doing a right-tailed test because we're doing greater than. So the p-value for this test is the probability that we would have a normal being greater than 2.85, which is equivalently the probability that a normal z would be less than negative 2.85. And if you look up negative 2.85 in your normal table, you'll get 0.0022. So if you're looking at the 5% level, we see this is less than an alpha of 0.05, and so we are going to reject the null. Which means that we have significant evidence that the population proportion of males afflicted with the disorder is higher than that of females. The conditions that should be checked here for this test to be valid are that when you take your sample size n times your p, that what you should get is something greater than 5. And so you can check that that holds for both groups, and then also that n times 1 minus p is greater than 5 for both groups.